Okay, class, this is pre-algebra lesson 8.1. So this is the first lesson of chapter 8, and we're going to be simplifying equations. All right, so as you remember, we've already dealt with equations earlier in the year, and we're coming back to them again, and going to learn a few more things involving the equations. So in your notes there, 8.1, simplifying equations. Don't forget the goal in solving equations. The goal is to isolate the variable. Isolate the variable. And again, what does that mean? Get the variable all by itself on one side of the equal sign, right? That's what we're looking to do. We're going to get the variable all by itself on one side of the equal sign. I'll remind you of a few more aspects of solving equations once we get to a couple examples. All right, so what's going to make this lesson different from what we've done before? And that's what's right here in this box. All right, so how? So there's a couple parts we're going to have to deal with. We're going to have to, first off, distribute. Now, we've also done this already earlier in the year, and so I'll refresh your memory on how to distribute. Distribute and or add like terms. All right. Sometimes you have to distribute, sometimes not. Sometimes you have to add like terms, sometimes not. That's why the and or. Okay. So we're going to distribute and or add like terms. And then remember, when quantities are both added to and multiplied times the variable, move things added first. It's going to allow us then to isolate the variable. Okay, so we're going to distribute, we're going to add like terms, and we're going to go from there. All right, so let's refresh our memory on the distributive property. All right, the distributive property is really, a full name is the distributive property of multiplication over addition. If you notice here in the blue box, we have an A that is multiplied times two things being added. So the distributive property of multiplication, the A, over addition, the B plus the C. That's where the name comes from. And so what we need to do is remember how to distribute. Okay, so what do? You take that A and you multiply it times the B. So I'm going to use my color here. I'm going to use a red A and then a black B, right? A times B is AB. Then the next distribution, we have an A times a C. So you've got that plus sign there. A positive A times a positive C is a positive A times C. So A times the quantity B plus C equals AB plus AC. Okay? All right, let's go through some of the examples here to try to get you back up to speed on distributing. It is an important aspect in math. Okay, so if you look at example number 1 here, let me close my window a little bit. Okay, so if you look at example 1, we're going to take the 3 and multiply it times the 2x. Okay? 3 times 2x is 6x. And now we're going to take that positive 3 and multiply it times a positive 4. Positive 3 times a positive 4 is a positive 12. You need that plus sign in there because you have to show the relationship of the two terms that are added and remaining. Okay, so 6x plus 12. In the second example, we have a negative 2 out front. And I've always taught you from day one, always include the sign with the number. So this is a negative 2 that we're distributing. Okay, so what do you get when you multiply a negative 2 times a 5a? Right, hopefully you're thinking negative 10a. What about a negative 2 times a positive 6? Negative times a positive is a negative. 2 times 6 is 12. And we end up with 10a minus 12. 10a minus 12. All right, let's do a couple more examples here. All right, so what about this next one? Well, again, we've got a negative out in front. All right, so if you want to try it yourself, go ahead and pause the video and then turn it back on when you're ready to go. All right, so 7 times 2y is a negative 14y. Now be careful here. This is a negative 7 times a negative 5. Negative times a negative is a positive. 7 times 5 is 35. And we get negative 14y plus 35. All right, in this next example, students don't like this. Some don't, because the variable's in the back. So we have two means of solving this. You can just go ahead and distribute even though the number's in the back. Or you can use the what property allows you to change the order. Are you thinking commutative? You can use the commutative property. So if you want to, you can switch the order. If I were to switch the order, I can put the 5 in the front and the 2x minus 3 behind it, right? I switched order, right? The 2x plus 3 went in the back, the 5 went in the front. Okay, I'm going to show you both ways. 2x times 5, 10x. Negative 3 times 5, negative 15. Now, I will say this. You can even do this one backwards if you want, and some students prefer that. There's really 3 ways. 5 times 2x is a 10x. 5 times a negative 3 is a negative 15. Hey, whichever one's easier for you, or you say, I don't like it, any of them when it's in the back. I'm just going to move it to the front. Okay. 5 times 2x, 10x. 5 times negative 3, negative 15. All right? No matter how you shake it, no matter what you do to it, if you do things properly, you'll get the same result. Okay? All right, so now let's get down to the actual solving of the equations, right? We're going to have to isolate our variable. And let me throw up one reminder here in the beginning, and then I'll mention a few more things. So I'm going to just put up here, remember, in green. Remember, we've talked about this before. You can only add like terms. You can only add like terms that are on the same side of the equal sign. That are on the same side of the equal sign. Okay, now that's real important. You can only add stuff on the same side. Now, we're going to move stuff, but the actual adding of like terms can only take place. Anything on the left can be added with anything on the left. Anything on the right can be added with anything on the right. All right, let's take a look at A here. Before we go any further, let me remind you a few other things about equations. The smartest method of solving equations is to maintain a left side and a right side, right? You got the equal sign there. You got the left side of the equal sign. You got the right side of the equal sign. Now remember, we can only add like terms on the same side. All right. I also taught you to only use one equal sign per line, and I also taught you to do your work below. That's the most efficient way to solve equations. All right. So let's go through. So if you see in the beginning, we have a situation where we can distribute. So that's what we want to do first. We want to do this before we try to isolate the variable. So this is all first. 4 times x, 4x. 4 times a positive 2, positive 8. We still have this plus 6. There's our equal sign and negative 8. Okay? Now we're ready to add like terms. We're going to add two numbers that are on the left. So we have a 4x, positive 8 and positive 6 is positive 14. There's our equal sign and negative 8. Now it's down to this. And if you'll take a look, you don't need to do this in your notes. I'm just trying to refresh your memory. All right, our variable is on the left. Therefore, we need to move two things. We need to move the 4, and we need to move the positive 14. The 4 is multiplied times the variable times the x. The 14 is added to the variable. Remember, when things are both added to and multiplied times the variable, move things added first. So we want to move that 14 first. How do you move something added to the variable? You move it by adding its opposite to both sides, right? So we're going to add a negative 14 to the left and a negative 14 to the right. That gives us a 4x on the left. Positive 14 minus 14 is 0. That's what we want. There's our minus sign. All right, be careful here. 8 negatives and 14 more negatives, 22 negatives. All right, at this point, we're ready to move to 4. Things multiplied times a variable are moved by multiplying both sides by the reciprocal. Remember, a 4 is a 4 over 1. I'll multiply the left side by 1 over 4. And I'll multiply the right side by 1 over 4. Again, I'll put the number over 1 to make it a little clearer what's going on. So on the left, the 4's divide out, leaving the x all by itself isolated. On the right, we have two fractions, right? But you're not going to forget 2r bum, are you? Let's reduce before we multiply. A 4 is a 2 times 2. And a negative 22 is a negative 11 times 2. And remember, guys, I'm trying to get you to think about the signs of your answer. We have a negative divided by a positive, so our answer better be negative. All right, so what's the top? Oh, our 2's divide out, right? So what are you left in the top? A negative 11. What are you left with in the bottom? A 2. And our answer is x equals negative 11 halves. X equals negative 11 halves. Okay? So you just follow it right along, all the procedures that we've learned already. Let's look at the second example. Okay, here's my equal sign, left side, right side. In this situation, our variable's on the right. So we'll get it isolated on the right. Okay? First thing you're going to do, and this one doesn't have any distributing, but it does have adding like terms. All right, so our next line, we still have the 18. We've got our equal sign. What happens when you add up to two things in the boxes? What do you get? And you should be thinking positive 3y and a negative 7y leaves you a negative 4y, right? 3 positives and 7 negatives leaves you 4 negatives of them. And we still have the plus 3. Okay, now we're ready to isolate the variable. Things added to the variable, we move first by adding their opposite to both sides. Add a negative 3 to the left, add a negative 3 to the right. We end up with, I said that backwards, add a negative 3 to the right, add a negative 3 to the left. All right, we end up with, on the left, 15 equals negative 4y. We got to move that negative 4, and you know, I wanted to do the first one by multiplying by the reciprocal, but remember, we can do a shortcut. We can divide the right side by a negative 4 and divide the left side by a negative 4. Same thing as multiplying by the reciprocal. The negative 4's divide out. Our right is the y all by itself. And in class, do you leave negatives in the denominator? You don't. There's no reducing of this because it doesn't reduce, and we get negative 15/4 equals y. Hey, that's the idea, and that's what we're doing. Let's do a couple more examples. All right, so example C, and again, if anytime you want to try them on your own, just go ahead and pause the video, and then you can turn it back on and see where we've gone since you tried the problem. All right, so on this one, we've got a couple things going on. First off, on the left side, I can add the like terms. All right, we all know that 15 minus 5 is 10. That's just a 10. On the right, though, we have distributing. Negative 2 times 3n is a negative 6n. Now be careful here. Negative 2 times a negative 3 is a positive 6. And we still have then, after that, the plus 3n. Okay, everything working below. Notice, again, on the right, I have some more like terms. I have a negative 6n and a positive 3n. So that's going to give me a negative 3n. Now, what else is still there? I still have the 10 on the left, and I still have the plus 6 on the right. Okay, it's an easy problem now. We've done these many times before. Move things added first by adding their opposite. Our variable is on the right. That means we need to move the negative 3 and the 6. Let's move the 6 by adding its opposite to both sides. Let's move the 3 by multiplying by the reciprocal, which in this case is exactly the same as dividing by negative 3. Hey, our variable is all isolated. Oops, it should be black. All isolated on the right-hand side. And again, did we leave a negative in the denominator? No. We put it in the numerator because a positive divided by a negative is a negative. We get negative 4/3. Okay? All right, look at D. In the world of distributing, you have to be careful because we do have this negative in front of this parentheses. Now, when you get better, you'll just distribute the negative. But in the meantime, students like to think of it as a -1. It's exactly the same thing. And if you'll distribute that -1, you'll be in great shape. So I'm going to use a little bit of color on this one. All right, so we still have the 5. You cannot, so before I go any further, let me just remind you, you cannot do 5 minus 1 is 4 and then distribute the 4. You're violating the order of operations. You're doing addition, and the -1 is multiplied times the quantity. You got to do multiplication first, so don't make that mistake. I'm going to take my red. -1 times a positive 2x is a negative 2x. -1 times a positive 7 is a negative 7. And then I still have my equal sign and the 3. Everybody okay with that? Okay, next line. All right, I got my negative 2x, and I can add now my 5 and my negative 7. They're on the same side of the equal sign. They're both on the left. I'm going to add them up. All right, 5 positives and 7 negatives leaves you 2 negatives. Now it's back to what we've done 100 times. Let's add a positive 2 to both sides and move that. Negative 2x equals 5. Let's move the negative 2. We've done that a bunch. We can divide both sides by the negative 2. And where do we end up with? X equals, negative goes in the top, not in the bottom, negative 5/2. Hey, not hard at all. Not hard at all. All right, let's do a couple more. Again, if at any time you want to do them on your own, pause the video, go ahead and work through them, and then turn it back to play to see if you've got it correct. All right, we got a couple things going on in E on the left-hand side, right? Everything's happening on the left. All right, be careful here. This looks like distributing, but it's not. This is just multiplication of 3 times a 2n. That's all it is. 3 times 2n is 6n. Now on the second one, here's distributing. Positive 3 times a 2n, positive 6n. Positive 3 times a -1, negative 3 equals 21. Okay, let's add up like terms. 6n and 6 more n is 12n. Still have the -3 equals 21. See, we're working below. We're keeping the equal sign with the left side and the right side. Things from above tell you what the next line is. All right, got to isolate the n. Let's get it all by itself on the left-hand side. We got to move the 12 and the -3. The -3 is added to the variable. It gets moved first. Going to add its opposite to both sides. 12n, by the way, this should always be 0, right? That's how you'll know you did the right thing. And then 21 plus 3 is 24. Finish off with the shortcut. Divide both sides by 12. And sure enough, n equals 2. I will remind you, you can always go back to the original and sub in the value to see if you have it correct. You should always do that after completing the quiz or completing the test and before turning it in. You don't want to check it as you go. You're not going to have time. You got to complete all the problems first before you go back and check. All right, last one, F. A couple things going on here. Remember, do not make the mistake of doing addition before multiplication. You cannot add the 7 and the -3. No, 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 no. We want to distribute the -3. Okay? So my 7 is still sitting there. Now, negative 3 times 2x, negative 6x. Negative 3 times a negative 4, be careful, positive 12. I still have plus x minus 20 equals, and I can go ahead and add the stuff on the right. What do you get? 4 negatives and 8 more negatives, 12 negatives, right? Okay, let's go ahead and work the left. I like to do my variables first. Negative 6x and a positive 1x. 6 negatives and 1 positive leaves you 5 negatives. Let's add our numbers. 7 plus 12 is 19. 19 minus 20. 19 positives and 20 negatives. Now remember, let me just refresh your memory. All right, let me show you down here. You got 19 positives and 20 negatives. Remember, these 19 positives wipe out 19 of the 20 negatives. And there's only one negative left. And the answer is negative 1. And remember the shortcut. Whenever you have one positive, one negative number, start at the lower number, don't worry about positive negatives, and count to the bigger. 19 to 20 is 1. Give the sign of the bigger, negative 1. All right? You guys are good at your positives and negatives. I just want to go back and refresh your memory on what we're doing. All right, come on, disappear. Thank you. Okay, so let's finish up the problem here. So what do we say? We ended up with a negative 1, equal sign, negative 12. All right, here we are, right back to what do you do when things are both added to and multiplied times the variable? Move things added first. Let's add the opposite of a negative 1 is a positive 1. Negative 5x, all right, be careful. 12 negatives and 1 positive leaves you 11 negatives. Things multiplied times the variable, you move by multiplying both sides by the reciprocal. And the shortcut is to divide by a negative 5. Uh-oh, finish it off. What's a negative divided by a negative is a positive, and x equals 11/5. Hey, that's the lesson. Let me go back, quick recap here. All right. Hey, what's the goal? Isolate the variable. In this situation, we're going to distribute. All right, we're going to distribute and or add like terms. Depends on what's there. And then you get down to moving things, right? All right, don't forget the distributive property. It's right here for you. It's there to go back and review. We did some examples of the distributive property here and here. And then don't forget my reminder. You can only add like terms that are on the same side of the equal sign, right? Don't forget, keep a left side and a right side. Move things away from the variable to the other side, whichever side that is, and you'll solve the equation. All right, that's the lesson. I hope that you have a great night.